Okay, so good morning, everyone. So today we have a guest, and our guest is joining us virtually. And our guest is Dr. Mohammod Irfan. Dr. Mohammod Irfan is a research colleague. I currently am working on a research project with him. We share so many interests in terms of climate change, global environmental change, trying to understand places, people, and trying to understand the different factors that shape people's health and well-being. And I thought it would be good to have him here since he's one of the main researchers and scientists that help create this tool that we are going to be using for the rest of our class. So, like I said, Dr. Efran is from University of Denver. He's a scientist at the Party Center, and that is where this tool is situated. And he's also a software developer. And like I said, his research interest has to do with using computational modules to understand global environmental change and understanding how, all the different subtexts that we've talked about, whether economic, population, the environment interact and how all of that shape people's health and well-being. So he's also in California at this time, I think. So it's about 7 a.m. So I just want to say thank you so much for joining us today and making time for us. And welcome and thanks again.
Thank you. Thank you, Thelma. Hello, everyone. It's a pleasure. Thank you, Thelma, for that very nice and kind introduction. It's a pleasure joining you, thanks to the technology, all the way from the other side of the other side of the world, other side of the country. But I guess it's possible these days to join, these sessions from uh, different sides of the world as well. Actually, I'm doing one this coming Saturday on modeling, where people will be joining from all over the world. So nice seeing you here. Let me, I will dive into talking about international futures because Chalma has already given some introduction. Just one note here, the Body Center has recently been turned into a research institute. Yay. In the University of Denver, with the wonderful leadership we have with our new director, Jonathan Moyer. Well, he has been director for almost 5-6 years now. And our founder, Dr. Barry Hughes, who actually started this modeling platform, International Futures. And I have been working with this model close to half of my life now. I did my, Selma was talking about my PhD. My PhD dissertation was actually developing an education model, a global education model for these international futures with connections with demography, economy, and all kinds of things. So without further ado, I will go into describing the model, and we will actually try to use the model together in the class today. Any questions so far for me for the center or for the international futures, or should I just go ahead? You guys can hear me okay, right?
Yeah.
Okay, so just one thing about the PowerPoint, and again, I will move back and forth between the PowerPoint and the model interface. Some of the, and I didn't want to do any animation actually on this, but some of the animation it's picked up from one of my older presentation, and you might see some weird animations, but just bear with me as we proceed. So let's move to the first slide, which is basically an overview of what we are going to do today. We'll of course talk about the international futures model, what it is, and I'll describe some of the modules, not all. And then we will talk about how to actually get the software so that you can use it for your research. And we will show, the help system and some of the interface. And then, of course, we will dive into the platform doing things together. Does that sound like a good plan?
Yeah.
Okay. So, international futures, which we actually call it IFS for International Future Systems. It's a large-scale integrated global modeling system. It facilitates dynamic analysis, so you can actually project variables over time. It is a global model, but it runs in most cases at the country level. So there are 188 countries. Pretty much every country in the world is included, except countries with very small population, which, when you're modeling them, it becomes difficult. Sometimes the patterns and projections don't make sense. So we don't take countries below a certain threshold of total population. The model can project from starting from some base year that the model developers choose till the current horizon is 2100. In the regular version of the model, we are actually some of our colleagues are actually looking into further beyond for a project where they will project the situation of the world for many different socioeconomic variables and emissions using the shared socioeconomic pathways, the scenarios that the global climate change researchers use. So in terms of the coverage of the model, this diagram, which we call the quilt, actually shows the different modules. So as you can see, it's actually a system of models. It's a platform where you have user interface also to use the model to look at projections that are already packaged or make your own projections by using a scenario, developing a scenario. So some of the major modules are listed here. We have a demographic module. Then we have an economic module. The two in the top in the middle, those are actually some of the core models in F system. As you can imagine, pretty much, all of the human system and social system variables will depend on the underlying population. If you're looking at access to, certain type of water and sanitation facilities, or schooling of children, enrollment rates, or educational attainment, or labor supply to the economy, everything is connected or is based on the population that goes underneath, right? So that's the demographic model, and I'll talk in detail about it when I go to that module. There's an economic model. Again, we'll go to the detail. And within demographics, there is health and education. We do diseases. We do births and deaths. We do life expectancy on the education. Again, I'll talk in detail. We have enrollments and attainment. Now, on the physical side of the model, we have an agriculture model, which we forecast agricultural demand, agricultural production, food demand, fodder demand, and then trade in the agriculture. So these are actually in the physical model projected as volumes, like metric tons of crop production or livestock meat production. And the economic model there, of course, in imports, exports, and intersectoral use, those are in dollar values, but there are connections among them. We have a small environment module. We actually project emissions, and those are driven by an energy model, which has production on energy disaggregated by energy types. So energy production in the model has oil production, gas production, and then coal production. And there are projection models on how the global society would transition from a fossil fuel based energy system to a renewable energy system. We have three types of renewables. The so-called other renewable, which is basically solar, wind, geothermal, etc., all aggregated. There is a hydro energy model, and there is also a nuclear module. On the political and social side, we have international politics represented. We have social political representation, the government finance, spending, and revenue collection. Those are also represented in the model. And these are all interconnected. So of course, the major relationships, the major patterns of relationships, for example, if we are talking about education, we are talking about student enrollment, which will depend on the incomes of the families, the demand for enrollment, right? At the same time, whether the students can come into schools and graduate will depend on the schooling places that are made available through funding at the public and the private level. So as you can see, and with the education completed, people will go into labor force and the productivity will increase as their educational levels increase. So all these connections are represented in the model, depending on the data availability and the understanding of the relationships. There are, of course, uncertainties, as you know, in many of the relationships, and the model handles uncertainties both through parameterization, calibration of the model, and through scenario analysis. So that's like a broad overview of the interconnectedness and integratedness of the model. It's a long-range global integrated model. There is a name actually that people use for this kind of model called integrated assessment models. Many times these models are coupled with environmental and ecosystem models. For example, I was talking about SSP. People will take the way the social economy will unfold in the next 100 years, and what kind of implications does that have for emissions. So if you have a highly fossil fuel driven and high economic growth society, your emissions will be much higher than in a sustainable pathway. So those kind of scenario analysis you can do with a model like this, with projecting the socio-economic outcomes, and then we can do some emissions in our environment model, or our socio-economic outcomes can be coupled with the physical system model. So that's kind of a short, brief overview about the ifs in a nutshell. Any questions at this point? Okay, I'll proceed. Yeah. Was there a question?
No.
No? Okay. So this is actually another way of doing that block diagram where you can see actually some of the connections. Of course, these connections are not we're not necessarily doing all the connections here, but just, the things that I was saying earlier, it shows how these are interconnected. For example, it shows the connection between, education and population. As I was saying, this to project enrollment headcounts, you need number of children in each of the school age groups. So for primary enrollment, you need children in the, say, 6 to 10 years or 11 years in a country, and that's projected in the population model. Financing in education goes from economic model, and it comes back, actually, you can see a bidirectional arrow. It comes back through productivity. Education is related to health. Education is related to fertility and mortality. So these are the connections that we are showing here. So this is kind of the use of the model, just, giving some of the use cases. It's heavily being used by international agencies and governments to project the unfolding of their country, regional, or global future that on specific issue areas or with research questions, like how does energy future look in sub-Saharan Africa? What does it mean in terms of human development in the region? Whether they should take a more polluting, high human development index early in the horizon, or they should really go take a sustainable path. Those kind of analysis. UNDP actually has just done a report with using our model for their underlying quantitative analysis. We did this PERDI PPHP series, Patterns of Potential Human Progress, back in the late first decade of this millennium, or century, actually, millennium also, right? Where we are talking in long term here. So there were 5 volumes and I have pictures for 3 here, cover pictures. They came out from Oxford University Press. There was poverty, the poverty volume was called Reducing Global Poverty, then Advancing Global Education, Building Global Infrastructure for Infrastructure. These are basically mid-century projections for all countries, all model countries, and then there were regional projections. And then we did a scenario of how it would look for if, and what kind of an integrated policy needs to be taken to get a better world. And then we also did a downside scenario in some of those, what if things go the wrong way, how would the world look in the future? So those are the analysis we did with those 5 volumes. The other 2 volumes, one was on governance, the other was on health. And then there is this International Futures book on the bottom right side of the screen. I don't know whether it's right or left on your end. Uh, that's written by Barry Hughes. I was talking about Barry started this model about 40, yeah, I think it's about 50 years from now. I don't know whether you guys heard about this book called Limits to Growth. People at MIT, Jay Forrester at MIT, and other researchers, they came up with this world model where they were actually showing. I mean, all this concern about sustainability, as you might know, started in these early 70s, late 60s. So they were doing computer models to show how the resources are constrained and what it means in terms of the way the population was growing at the moment, and what it would mean in terms of the capacity constraints and all those. It was a pretty gloomy picture, but of course that as you know, late 70s, there was this oil crisis in the mid 70s, early 70s, but then there was this period of IT driven growth. So this kind of went somewhat in the back burner, all this gloomy projections. But nowadays, this has all come back with especially the increasing understanding about the interconnectedness of these different variables and different issue areas, so that those transversal relationships, the cross-cutting relationships, these could not be captured with models which focus on a specific thing. Like if you have a model of GDP growth only, it does not show you how GDP growth can be affected, or GDP growth can increase as you educate people, or how it can decrease as you have some kind of shocks in the system. So that's when this model, which Barry has started developing with a group of people, not the Jay Forrester group, the other group, another group, um, um, who also worked on I remember 2 names, Mike Masarovich and Pastel. So Barry had this model. He has actually moved it from Quick Basic to Visual Basic. Now it's in visualbasic.net. So it has, as far as I know, this is one of the very few models which can actually capture this multiple interactions in multiple issue areas for all the countries for over a long time. And of course, uh, having said all this, we also have to be modest about what a model can and cannot do. We have to remember, this is model, there are simplifications, there are assumptions, and there are limitations of your understanding. So we do the best we can do with a model like this, and we interpret it with skepticism. Uh, I personally think uh, uh, this is more of a learning tool as opposed to making specific point predictions that some of the, specifically models in the physical system, or more and more this big data driven models which work for businesses these days. They use the term prediction because they want to know the exact amount of sale that they can make given an action or price decline the price action that they take. In our case, we look at patterns. We try to understand the relationships. We bring in the data. We analyze the data into relationships. We put them together, and we see how things are going. It might be misleading to consider those as point predictions. The two terms we use and we like to use are projections and forecasts, which are, again, gives you an estimate or an understanding of how things are unfolding, but not necessarily the exact number all the time. Okay, so any questions so far on the use of the model, the blocks, or anything that I have said so far? Okay, excuse me, let me go to the next slide here. So these are a list of some of the publications. This is actually an year old. We have done some more in the meantime. In the last year, there were 2 papers actually, and there are a few on the pipeline. Especially, we did one where we looked at poverty for all 5 SSPs with the pandemic impact on. Uh, so now, Chalma, you have the PowerPoint from me and you can share this with people, right? So I'll just, without going into the detail, I'll go into the next slide. These are some results. When you run the model, actually, this thing keeps on moving and showing you the projections. As you run the model, after you build a scenario, these are showing 4 major trends for the model base year, which is 2019 to 2100. And it runs till 2100. And you can see how the population is going towards the peak and kind of stabilizing. GDP keeps on growing. World forest first declines and then comes back in kind of inverted U curve. Well, actually, it is the U curve, not the inverted U. And then you see the CO2 emission as parts per million. One more result, this is global population actually disaggregated into age groups, and it shows millions of people living in extreme poverty. These are some of the results that you can do by running your scenarios. You can display data. This is a projection of our results on maps. That's also something you can do with ifs. Okay, so let's talk a little bit about some of the models. Again, this is something as I go into the interface, I will show you where to get more details on these things. I believe not everyone is interested in all the details. You have specific focus and research area. But the good thing about the model is it helps you, even if you're not an expert or if you don't want to dig into a certain area, it gives you a broad overview of how your area is interconnected with other issue areas. So that's why I like to go into the different modules and look into the details of what is under the hood. So this is talking about our economic model. As I was saying, economic and demographic are 2 core models. So it's a general equilibrium model. It represents supply, demand, and international trade. There are 6 sectors: agriculture, primary energy, raw materials, manufacture, service, and ICT. And as I was explaining earlier, agriculture and primary energy also has a physical model, but in the economic model, they come actually in dollar values. There is labor represented by skill level, and skill comes from the educational attainment. Basically, what we do is, adults with completed elementary and lower secondary education are put into labor available in the low skill category, and then upper secondary and tertiary is termed as labor with high skills. And employments are also in the model by skill levels. So this employment by sector and intersectoral flows, which is, as you know, in the economy, the productions are either used by the consumers, people like us, for the final demand. They could be exported or imported for consumers in other countries. But also there's another use of the goods that we produce, which is as an input to other production, right? For example, energy is an example of an input which is used in all kinds of other, like service of heating your house, or making other energy-based products. So the model actually keeps track of this input-output flows, export and import, and final demand using a IO matrix, and the data for that is actually collected from this Global Trade and Analysis Project, GTOP. It's a project at Purdue. They are collecting input and output and import and export flows for a large number of countries, like our model. I think the last output was about 100 and the last version, which is GTAB 11, is 161 countries. So we initialize the data with their data. So I was talking about demography. I'm talking now about economics. I talked about education. And I said the model starts in 2019 and runs till 2100. So there is, of course, this relationships like how much of economic input or government spending input will give how much student enrollment. Those relationships are derived using historical data, which we collect as country year tables. Like we'll have a table where there are all the countries in rows and tables, years in columns, and we'll use those data to analyze relationships. Now, when the model starts in the base year, which right now is 2019, but this is flexible, we can make it, 2020 or 2021. Why is it that we are actually, who can tell why is it that the model is based on 2019 now, even though it's 2024? Would you like to take a guess at it?
For COVID?
COVID is actually keeping us from going to 2020 because things are quite different in 2020, and model initialization within year, which had a shock, might give us some unwanted and counterintuitive projection trends. So COVID is one reason we are hesitant to go to 2020. But why not 2021? Let's say there was no COVID. Why would a model be 3 to 4 years back, a model like this? What would be some logistic challenges? So if you want to do the projections for a certain number of years, you need to start the model at some point, right? So that's what 2019 is. And what do we need to start 2019? Sorry, I couldn't hear it. Can you say it a little louder?
You need historical data, is that what you mean?
Exactly. So we need the data to initialize our variables. So if I'm looking at enrollment rate for a country like India in elementary level, I need to know what was the enrollment in the year 2019 or 2017 was, whichever my base year is. And then I go from there, then I will have a relationship which will tell me, given this much population, given this much spending, this much income of the families, the enrollment will go, say, from 67% in 2019 to 67.5% in 2020. So the model needs to start with data. And guess what? With a model with this kind of coverage, it's very difficult to get the data that we need right away. So the global databases, I talked about GTAB. Many of our data are collected from, I'm sure you guys have heard about World Development Indicators. By the way, if I'm looking at the other screen, that doesn't mean I'm looking away from you. I have two screen setups, and you guys are on my right screen, and my PowerPoint is on my left screen. And so when I look at you, I feel like I'm looking at you. I'm actually looking away, right? So the global database that are provided for us to initialize our models, World Development Indicators from World Bank, or UNESCO for education data, or where would we get the energy data from? Where would you go for our energy data? Does anyone have any idea? If I want to get energy data for all countries in the world, how much gas they're producing, how much oil they're producing. International Energy Agency could be one. They actually come up with World Energy Outlook every year. I don't know, is it every year or every other year? And then for economic data, both World Bank and IMF, they do World Economic Outlook For agriculture data, where would you go if you wanted data that covers all the countries in the world? What would be a good place? We can go to FAO, Food and Agricultural Organization from UN. So we collect data from these global agencies, and they are usually behind by a couple, 3-4 years. And then again, usually the data for the most recent years are not as uh, as good or as much as we would need to have a good model. So we are usually behind by 4 to 5 years in terms of our model base here. So this is the diagram of the economic model, the block diagram of the economic model. As I was saying, there are labor and there is production, total production, and then production for final demand versus production for other sectors, going through this so-called input-output matrix or the A matrix. And there is value added in the model, which is factor payments that are made to the labor and to the people who invest capital. And those factor payments go into the income distribution, which into the households that actually that income determines the consumption level, and then poverty, and then the inequality in the society. So all these relationships, we try to put it in the block diagram. In terms of the equilibration, economists use the analytical general equilibrium model. What we do is something called equilibrium seeking model, where the model actually has a stock of inventory in the middle. So there are demands and there are supplies. And as the in a year where there are more supplies than the demands, inventory will build up, and then that will send a signal back to the production, which will then actually cut down on the production. So that's the kind of equilibrium seeking structure that we have in the model. The model runs in annual time steps. So each year the inventory is built up. Next year it works on the inventory that's built up so far. And the production and supply demand for the particular year. Any questions on the economic model? Okay, let's go to the next one. So I'm showing the demographic model here. So major flows in the stock of population is, of course, there are births coming in and there are deaths going out, and then there are migrants which can both go out and in. And the flows of births, there is this variable called total fertility rate, which is the number of children and average women in the reproductive age in their lifetime, the number of children they give birth to. So there are data on that, and that's driven in the model by economic, the income level and education of the women. So that together with the current number of men and women in the society will give you, the births that will go into population. Deaths has a very detailed model driven by death categories, like, there are communicable diseases, non-communicable diseases, and then within the non-communicable, there are heart diseases, cancers. We collect data from Global Burden of Disease database at University of Washington. And all these deaths will actually determine ultimately the life expectancy of the population. And then there's migration, which has a model by push and pull factors on migration. Population is actually disaggregated into 5-year age groups, and with each 5-year age group is also disaggregated into single-year age groups. So basically, we project population for every single age, but the model output actually shows you by 5-year age groups. The reason we do that is many of the variables are, when you look at their interaction with population, is the demographic age structure that's important. I talked about schooling before. Similarly, for economic productivity, you have labor going from, say, 15 to 65, or with increased aging in the world these days, maybe 15 to 70 or 75. but not everyone in the population is in the labor force. Any question on the demographic model? Okay, so those are big models, we call them modules, demography and economics. Now, within each of the modules, there are smaller models which sit inside, like education sits inside demography, health sits inside demography. I gave you some ideas of education before. So basically, we have 4 levels of education represented: tertiary, elementary, secondary, upper, secondary, lower, and tertiary. And we have length of schooling. So children, when they're of entrance age population, the model uses the intake rate to bring children into school. That intake rate is actually driven by family income, which is a big determinant of demand for education in the model. And then with the entrance, there is also a rate of persistence across grades. So there's this metric called survival rate, which gives you basically percentage of entrants who persist to the last grade of the schooling. Again, the data comes from UNESCO. We do the analysis, how they change as countries' income level change. So using those rates, we determine the number of students in the school. And that goes into economic model as the government finance model, because it will then ask for the funds that are needed to run the education sector in the country. So I told you about, I discussed the number of people or number of children, number of pupils, actually, number of students. What else would we need to compute the fund requirement for education? In addition to number of students, what other variable will we need? If you are the education minister of the country, and if you are actually given the task of asking the finance minister, hey, I'll need this much money for the education sector next year. You'll of course need to know what is the projected enrollment. What else would you need to know?
What resources the students will need,
Sorry?
the cost of resources for the students.
Exactly. The other one is, of course, the cost of. So there is this metric that UNESCO does called, per student spending by level of education. Of course, cost of for one children in the elementary school is much different from the cost that you pay. The University of Connecticut pays Telma for teaching one of you, right? It's quite different. So those different costs, there are global numbers, and we project those. And with the cost and the enrollment, we determine the funding. And then, of course, once the education minister estimates the fund requirement and goes to the finance minister asking for that amount of fund for education sector in the subsequent year, would the finance minister be available to give all the funds? Maybe or maybe not, right? Depending on what other sectors are asking for. So remember, in the model, we have infrastructure, we have health, and then there is defense spending, there is R&D spending. So the government finance in IFS has all these representation of different government consumption. And depending on the budget requirement on other sectors, model has an algorithm to give, to allocate a certain amount. And then the model goes back to the education sector with that amount. And that, of course, will mean that, the number of children that was initially projected, they have enough fund. They might have a little bit more fund. They might have less fund. If there is less more, there could be two things that the education minister can do, right? She can either cut down on enrollment, which nobody wants to, or can cut down on teacher salary on the cost side, which is also a big political issue. But again, the model actually incorporates all those, represents all those in the simulation. This is the model that, Telma was talking about. We're doing a research project. So this is the model that we used there. This is the water and sanitation systems in a country. As you know, as some of you might know, the JMP and WHO, the Joint Monitoring Project, I think it's WHO and UNICEF, they've come up with this categorization of water and sanitation facilities in a society based on whether it's safe, whether it's easily available, whether you have to take a trip to it, whether it takes more than 30 minutes, whether the water that you drink is polluted or contaminated or not, and whether the sanitation facilities that you use is connected with the sewer system. So, but they have come up with this 5-tier system called as, for water, they're called surface water, unimproved water, limited type, basic type, and safe type. Similar categorization, 5-category categorization are there for sanitation, with the one at the bottom being open defecation, which is a reality in many countries. And then they collect data on the share of people in each country or share of households who fall into one of these categories, or their services are one of these types. And we collect that data when we project that into the future. We drive it by a logistic model, which is the type of statistical model you use for category data. The models are driven by education, poverty, and income, talking about interaction once again. And then again, the projection goes into government finance, and depending on whether the funds are available, there's of course cost of each type of service. So percentage of people and the cost together determines fund requirement, goes into the government finance, government budget process right here. And depending on fund allocation, you have final projection. Pretty easy, huh? Does it sound easy in terms of modeling this thing?
Maybe.
Does it sound easy conceptually to follow? As they say, the devil is in the details. So you can imagine with 188 countries, and then urban and rural for each of the country, and then these 5 different types, and then 10 different costs. Having everything in line can become a nightmare. You can have, everything working in the model, but then there might be 2 countries which you are working with, and you can find out projections that don't work, and that might keep you awake for the whole night. I hope not, right? Let's go to the next one. Okay, so more or less, I mean, we have, I think by now, my expectation is everyone in the class will have some understanding of what the model is, what it covers temporally and spatially, how it can be used, how it is structured, what is under the hood to some extent. I mean, as I said, this has been being developed for 50 years now, so it's very difficult to get it, all absorbed in 50 minutes. But I want to make sure before I go into using the model, I want to make sure that we have at least some common grasp of, what it is, what the devil is, and what it does. Are we there, or do you have questions for me at this point? Because from now on, we'll go and we'll try to use the model. So if there is any conceptual question, now is the time to revise that.
Any questions? No questions, please.
Okay. So this is, of course, available as a software application, as a computer software, which it's a freely available open source. There's a graphical user interface will go. There are 2 versions now. One is a web version. This might be something you have already seen in emails from your faculty, from your professor. So the web version is something you can use entirely using a browser from any operating system. But that version does not have everything. There is a desktop version which is a Windows PC desktop version as of now. We are working on taking it, making it available for Mac and other operating system also. One development we made in that direction is it's now like the web version, it also runs in a browser in the PC now. So even though it's a PC version, it's a version that runs in your browser using Internet Information Server as a local web server. And you can download it. There is a link here for the most recent version, which is 8.19. And there was installation instructions we also shared. Have anyone been able to install it in your computer yet? Did anyone try? Did anyone face any problem if they tried? No?
Not yet.
Okay. Okay, so so as I said, there's a menu-driven GUI, there's extensive help system, there is many of the menu options are self-explanatory, and then there are block diagrams of modules in the help system that we shared, and this is like a screenshot of the help system, which, you know, if this is your landing page or go-to page for IF's resources, IF's help, this is actually, as you can see here, this is organized into display, scenario analysis, data analysis, and then of course, learning about the model. So this top three are actually three ways we suggest that people can, start using the model, and I will discuss all three of these. And the learning about the model is where, I was showing all the interactions and modules. So with that, I believe this is my last PowerPoint slide. There's this driver diagram, which is for individual variables. You can right click on it, and it will show the connections of that variable with other variables. Let's dive into ifs. Okay, so this .NET version based on browser, this is a work in progress, and I'm using actually this is the web version. Yeah, I'm using the version in the web, and I personally use the desktop all the time, which, since I developed, there are features there which is needed for development. So I'm not very familiar with what is or is not in here. So I might stumble some of the times. Feel free to ask me questions, or feel free to follow along and do it yourself. Have everyone been able to go into this web page?
Okay, can you try to get into, if you go to Husky CT, there's a folder on IFS and on X, and you can connect on that.
While we are talking, let me actually open my local version just in case.
Husky CT content area.
Is it just the website?
So if you get to the website, can you scroll down?
I could drop it in the chat. The thing is, I'm not a big WebEx user. I think this is the only time I use WebEx, with this class.
So we are trying to get to the web page. So, sorry? No, this is it.
Okay.
Where is chat on WebEx? Trying to find.
Should be IFS online. So if you go to the web page, just scroll down, you'd see IFS online. We click on that. Have we clicked on it?
Yeah, I think that's loading.
Okay.
Can you click out alive?
Let's use the online version for now. And we can do the downloads later.
Is there like a pop-up? Is that?
No, it just refreshes until.
So
Yes.
I think
Do
it's.
you guys
just-
have the link for the page?
Yeah, we have.
Yes, they have the link. Did it pop up yet?
Yeah.
For you? Okay. Good.
It takes a little bit.
Yeah, I think it's it. Okay. Sorry.
Who needs help getting to it? Just for
I see a hand in the back, yeah. So as you can see, this one is my local version, local host. So if you install the desktop, that's what you'll see, as opposed to this one, which is coming from World Wide Web. And as I was saying, it looks all the same, but there'll be some features that are available in the local version. Saving the files and everything is also much easier. And in the link that I shared with your professor, you can go and download, and then this is just an exe. You can, and there are prompts which are self-explanatory. You can just go ahead and install it. It will download as you are, if you install the desktop version, there will be large data files that will be copied in your computer. And the installation instruction that I sent in a Word file, that should actually tell you about the kind of space. I would say about 10 gig or so available to install the software in your machine.
Okay, I think everybody has it now.
Okay, so we were talking about this three features, display, scenario analysis, and data analysis. So of course the model starts here, which is basically a map of all the countries. And if you select it, it shows HDI. This is actually projection of HDI. And this is, as you know, HDI is an index going from 0 to 1. And this is being here using color shades. But the main action is here. One of the things you can see first is this version on top. So as I was saying, the web version is different. And it's, as you can see also, this is behind, it's 8.06. This one here is 8.17. In fact, when the link that I sent you is 8.19, there's a reason I'm 2 versions behind is I'm doing some projects which uses 8.17 and things have changed in between 17 and 19. So I decided to hang on to 8.17.
So right now we have the online version. What version is that?
It's 8.0. Do you guys see my screen?
Yes.
Yes. So 8.06 is what you see now, right?
Yeah.
So that's the current web version, and web version is actually uploaded like once every 6 months or so, twice in the year. So it will always be behind from the most recent version, and most recent version would be in that link of our FTP server that I have shared with the professor. This is a work in progress. I think, even in this month, there were 2 versions. There are like 4 or 5 right now, 1, 2, 3, 4 core developers, but then there's a group of users. They always come up with feature requests, bugs, and we keep on adding things on the interface and on the model. So the versions continually change. Okay. Okay. So the interface here, the top menu is where everything is. So data analysis, scenario analysis, and display, those are the 3 main functions. Let's talk about each of these. So data analysis, remember I was saying that 2 purposes of the data that we have while developing this model. One is, of course, initialize the model. The model has to start where the world is at the point. We start with a snapshot in our base year and then go from there. So to initialize, we need data for that year. The second use of data is understanding the relationships or estimating the relationships or calibrating the model with relationships that will project the dynamics, that will take variables forward in time, or what kind of entrance rate change you can imagine as countries per capita income changes from $2,000 PPP to say $2,500 PPP. So those relationships are in the model in terms of statistical functions in most cases, or table functions. Table functions are functions which are drawn based on empirical estimation. But most of the functions are statistically drawn functions. So those are derived from data. So you can imagine over the years, we have actually gathered a huge amount of database. So even if someone is not using this model for projection, you can use it for your data analysis. And the data can be analyzed either into either cross-sectionally or longitudinally. Anyone familiar with the difference? Anyone want to actually talk about the difference between the two, longitudinal and cross-sectional?
Is the longitudinal just like when you measure something over a long period of time several times, and the sectional is just once?
Yes.
Right. So yeah, so you can take the cross-section of all the countries at a certain point in time, or you can take all the years for a certain country or a group of countries, for one or more countries, for a longitudinal analysis. So over time or across space is an easy way of remembering. It's not exactly a scientific definition. It's across your entities or over time. So for cross-sectional analysis, you can take any variable. Say you want to take TFR. Remember we talked about how total fertility rate is the major driver of births in the demographic model. So it's a variable which is measured at live births for women in their lifetime, which is basically the reproductive age. 15 to 55 is the age band right now in the model. And we collect data from UNPD, United Nations Population Division. So you select that and it will tell you which years do you have in our database. So which time periods are included in the database. Again, we don't create the data. The data is borrowed from international agencies. It's a global data set. So usually when I want to do something like that, I select most recent because it's a pretty full data set, but the database might have a skimpy coverage towards the end of the database for the most recent years. So if I take most recent, it will pick up whatever the most recent data. And for a data like this, for a data series like this, most of the data will be 2015 or later. So if the country does not have 2019, it would maybe pick up 2015 if that's available. In that way, it will increase my sample size. So that's the reason I select. But you can also select a specific year. So earliest and most recent, actually, when we bring in the data, we have this interface to extract and import data from other sources. So as the data is being imported, it goes through all the year columns and identifies the most recent data and put it in the most recent column, and earliest data puts it in the earliest column. And then during analysis, we choose this so that our sample size goes up. So this is TFR, most recent, and it has taken it for all countries. Now I'll do actually a regression. So this is my dependent variable. And let's say we want to see how the TFR change as the country's income level change. Which countries actually have large TFRs and which countries have low TFRs? What is the range of TFR, total fertility rate? It's number of live births in lifetime, right? So what would be a good guess, given the society we are in? What would be the number? If I ask you that what is the TFR, given that I have given the definition for what TFR is, if I ask you to make a guess about the TFR for USA, what would be your guess? Anyone wants to take a guess? Yes.
Yeah.
Is it 1?
Somebody says 1.
Okay.
Is that the same as the Human Development Index? Is that related?
So Human Development Index is an index of three different variables, the composite index of income, life expectancy, and education. We are talking about the total fertility rate, which is defined as the number of live births that a woman would give in their lifetime. So what is the average number of children that families have?
Is that like 2.5 in America?
It could be 2.5, but you would be surprised maybe if it is not 2.5. Now, if we want to say uh, every family has a boy and a girl, it would be 2. Maybe that's the reason you thought maybe some families have more than 3 or 4. That's why it's an average of 2.5. The replacement fertility rate is 2.1 because some of the children die. So if you want to keep your population stable, right? Man and wife, a family, 2 adults giving birth to 2 children, you might think there's the stability, but because children will also die, 2.1 is the replacement level. Many of the high income countries have their fertility rate well below 2.1. That's a concern. The so-called aging societies is because the fertility rate is lower, right? So US is an exception. Not only because of high fertility rate, because of the high migration. The population here is not actually going down, but there are countries like Japan and Italy where fertility rate is actually well below 2. It's 1.6, 1.7. Or for Italy, I think it's in the range of 1.2 or 1.3. I don't remember the exact number, but it's a very low number, which means over time the population is going to decline. And if you run the model long enough, which one of our colleagues is running for a 2200 model, it's actually running the model till 2200, and fertility rate is converging towards 1.7. After 2050 or so, 2150 actually, looks like there is no people in the world. There was actually a story in the New York Times towards the beginning of the year where they mentioned some research at University of Houston, Dennis Pierce. He ran models with putting everyone in the US fertility rate now. Now, putting everyone in the US fertility rate means whole world. So some of the African countries have TFR at the range of 4 to 5. Putting everyone the US level now actually runs the world out of population by 2300.
Mohammed, sorry to cut you. We have 10 minutes more.
Okay, so let's try to use the model a little bit. So if you want to do an analysis, we will take GDP here, GDP per capita. This is the GDP variable. I will also take it for most recent. So we have independent and dependent variable. Now, if we want to plot it, we'll hit here. So it's showing you a nice downward sloping pattern. You can do a fit of a curve. It'll give you the relationship. So you already have a model. You can use that to do a forecast. If you know the GDP per capita, you can actually project what the TFR is. Okay, so that's data analysis. Let's now go back to main menu. Any question on this? Let's go back to main menu. Now this display here is, this one is the one where, people like to go most often. This is where we package our projections that we have already done. The model has a base case, which is the world continuing, not necessarily exactly the same trend, but with using same kind of relationships, people grow, they die, there are diseases in the world, and then people graduate from schools, they go from worse kind of water and sanitation facilities to try to afford better ones. All these trends are put into a base run. That's here, model base run. And then we have packaged some other runs. This is a high damage, is basically the COVID making a lot of damage in the world. This is a counterfactual with no COVID. This is the SDG scenario where world is pushing a lot of policies to attain the SDGs, the Sustainable Development Goals. So each of these forecasts are packaged for all model countries. So if you can go to a certain country, like you can take Ghana, for example, and you can take water and sanitation, actually showing water here. Water connections, say piped water connection. This is actually older categorization of water and sanitation. This is a 3 category as opposed to 5. And then you can see, what happens in the base case versus the SDG push. We're doing a line graph. This is a history purpose forecast. The historical data starts at the year 2000. It shows this is the base case. This is what with the push. This is what the policy interventions. This is what is going to happen for the country. So these are pre-packaged. Now, the question is, how do you build your own scenario? Right? So to make your own scenario, any questions so far?
No.
So to build your own scenario, you'll go to the scenario screen. And then if you want to say increase or decrease the TFR, you will have to select the parameter. The parameters are either in this tree, which is organized into issue areas and agents. Policies can be made at the household level. Households can make their decisions. The decisions can be made at the household level or government levels or international level, or they could be made in different issue areas. So if someone is not familiar with what the different variables are, you can go to each, but what area you want to work, you can select all of those and it will allow you to select your model driver. But you can also go to this search, and if you know that you are looking for a parameter on TFR, I'll put TFR there, I'll put the search, and then let's say there is a TFR and it's a multiplier on TFR. Okay, we have selected it, we will load it, and it'll give you a choice of countries. Let's say we take Ghana. So this multiplier is 1 now, which means if you run the model as is, the TFR is going to run the same pathway as our base model is. Now, if you want to decrease the TFR over time, you can either use this slider, you can do fully customization, or you can just put this option button on low. So it's basically lowering it by 80% to 80% of what the base projection is. It's not lowering it by 80% of the initial year value. It's lowering it relative to the base path over a period of 10 years. You can also lower it to a different value by using the slider and over a longer period. If you think 10 years is not enough to get the TFR down so fast, you can use that. But this is your scenario. You can get 10 of these or 20 of these. And as when you do it, what the model is doing is in the back end, the model is creating this SCE files, which are basically definitions of what you have done. See, this is my multiplier, these are the years, etc. And then you have to run the model. Okay. So I tell the model how far to go, and telling it to go to 2040, say start run. Now it will actually start running this assumption, and it will run the full model with this assumption for TFR lowered in Ghana. And you can save this SC, and it also does another file called .run where all the model results are. But use the definition, scenario definition goes into this SC, and you can bring it back later. You can rerun, and then you can compare your results. Like I was comparing the SDG push with base, you would be able to compare your run with the scenario that you are building. It's taking some time. Hopefully it will run. Sometime it does that in my machine. If okay, it started to run. See that it's having those 4 plots that I have shown in the PowerPoint. It is already run till 2031. That's one thing that we have achieved with the .NET version. It runs faster than our earlier version. I know I'm over by a couple of minutes already. I'll just show the results and finish it there. Okay, so it has run till 2040. We'll wait till it says here that it's run. So it says run successful. Okay. Now, if I go to Flex Display, so this is my scenario, which is now, it's my working file. So this is my working run, and this was my base run. And then I changed the scenario for Ghana, right? And let's see where I did it for. So this is organized into display issue areas, the display names, geography, and dimensions. So I will take population because I changed TFR. Let's first see if TFR is here, then we'll see that we were able to make the change in the variable or not. Total fertility rate, this is again history and forecast. 2040 line graphs. So see how the TFR is coming down faster, because that's the scenario I built. Now let's see what changes it brought to the population, because that's what we want to do. So population in millions, with that changes in TFR. Ghana's TFR declining faster. This is the change in population. Instead of going to 44 million by 2040, it went down to 42 million. Now, if you want to save this, of course, you cannot save the run files. You can bring in pre-saved run files that we run, but for the web version, I mean, for the local version, you can save your run files. That's one of the reasons you want to go to the local version, desktop version. For the web version, what you can do is, in the scenario analysis, you can name and save files in your own folder, and they're saved actually for 90 days. It used to be 60 days. For the course, I told our developers to make it 90 days so that you have it available for you. Once you save it, you can also import it later. You can open it using this menu option here. Okay, that's all I have for now. I didn't leave any time for questions. Well, I asked for questions in between, but if you have some more, I know you have to go. The class is almost done, but if you have quick questions, I'd be able to answer now.
I have a quick question. With the second scenario that you built, did you choose only population, or you chose TFR, total fertility rate as well? Did you choose the only population, or you chose total fertility rate?
So the population is the outcome variable, right? And if the population can change either by more births, more deaths, or less births, less deaths, or by migration. So I tried to change births by tweaking the parameter called TFR. So I changed births by changing TFR, or total fertility rate, which brought changes in the population. In the scenario screen, I changed fertility. This.
So what I'm referring to is when you went to the display tab.
Yeah.
The second scenario that you built with the display tab, when you're trying to show us the graphs, did you choose only population to see how the working file and the base file would turn out, or you chose total fertility rate as well? So you chose population from the display panel, right?
Yeah, so first of all, I choose the scenarios. Right now, this is my working scenario because I'm working on it. I have not saved it. So that's why you see that bottom box, 0 working file, and then the base file is the one with which I'll compare. And I choose the horizon for which I'll make the comparison. And I choose the country because I made the change in Ghana. So my expectation is it will bring changes in Ghana. So I choose my country. And then now I go which display. And so all these displays are categorized. So I know fertility and the overall population is the population category. And first I chose TFR because this is a variable where I put the parameter. I know ultimately it will change population, but I wanted to make sure that the parameter on fertility is working. So that's why I have shown the fertility first.
Okay.
And then I said, okay, now let's see what it has done to population. So now I chose population.
Okay.
By the way, you can do actually multi-select in many of these variables. So if you hit the control, you can actually choose two variables. But of course, for these two, seeing them together in one plot won't make sense because the units are so different.
Okay. So
Any other
I
questions?
just, any
Yeah.
questions before we go? It's time already. I just want to say, Dr. Irfan, thank you so much for making time to share your work with us. And let me stop recording before
Sure.
I lose it. Okay.